Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about counting. Now let's continue talking about the successive drawing, but in this case we will talk about the successive drawing with replacement. Omega is a sample space. In a successive drawing with replacement, we select one item, we replace it back, then we select another item, we replace it back, and then we select a third item, we replace it back, and so on. Thus, an item could be selected in this case more than once, and the order is very important. Let's see this activity. An urn contains 7 red and 5 blue. 3 balls are selected randomly and successively with the replacement from you. The first question, how many balls do we have in the urn? We see that we have 12 balls. Now, if we select one ball successively with replacement from you, how many different balls would still be in the urn? We're going, in fact, to have 12 balls because we've replaced the ball back. Then if we select another ball, also we're going to have 12 balls. And if we select a third ball, we will have 12 balls. Then what do you notice concerning the number of different balls? In fact, we can see that the number of balls remains as it is each time we select one ball. So in a successive drawing with replacement, the total number of balls doesn't change. We saw before that the total number of balls decreases by 1, but in this case we see that the total number of balls remains as it is. Now let's see this activity. An urn contains 2 red, 2 black, and 1 green ball, and we need to select 2 balls successively with the replacement from you, and the question is to find the number of different ways. As we did before, the first ball could be R1, now the second ball could be R1, because here we replaced R1 back to the urn, or R2, or B1, or B2, or G. So these are the different cases. Now the first could also be R2. So the second is R1 or R2, B1 or B2 or G. And these are the different cases and so on. We can see that in each case we have 5 different selections and we have 5 sets. So the question is how many different ways can these balls be selected, and the answer is the balls could be selected in 25 different ways, and this 25 is 5 multiplied by 5. Let's see the results. So in a successive selection with the replacement of P items out of N items, first we see that the total number of items remains as it is without any change, and we can see that the number of possible selections is n multiplied by n multiplied by n, which is n to the power p. So we have here, in fact, two differences between this case and the previous case. In the previous case, we saw that the total decreases by 1, whereas here the total remains as it is. And in the previous case, in the case of successively without replacement, we saw that the number of possible selections is an arrangement, whereas here it will be n to the power p. V contains 10 balls. We need to select 4 balls successively with replacement. You have to pay attention to the type of selection, whether it's successive or simultaneous, and in case it is successive, pay more attention to see whether it's a successive drawing with replacement or without replacement. The question is to find the number of different ways. So we have 10 balls. We need to select 4 balls successively with replacement. If we just apply this result, we get 10 times 10 times 10 times 10, which is 10,000. So we take the total and we multiply it by itself 4 times. How do we get this 4? That's it. Or we can use 10 to the power 4, which is also 10,000. Now let's see this application. In a truck, we have 15 big boxes and 12 small boxes. 3 boxes are to be selected randomly and successively with replacement from the track. The question is to find the number of different ways. So pay attention, we have 27 boxes and we need to choose 3 boxes successively with the replacement. Try to do it alone. So the answer is 27 times 27 times 27, which is this quantity, or simply 27 to the power 3. Now an NU contains 4 red balls, 7 black balls, and 3 green balls. 3 balls are to be selected, one after another with the replacement from U. So successively with the replacement. So in fact we have 14 balls and we need to choose the 3 balls out of them successively with the replacement. In how many different ways can these balls be selected? It will be 14 times 14 times 14, or 14 cubed, which is 2744 different ways. Now, in how many different ways can these balls be selected if they have 3 different colors? Now, here we have a certain condition that should be satisfied. So, we try to see this condition. Well, we have here 3 different colors. So, these balls could be red, black, green, red, green, black, black, red, green, black, green, red, green, red, black, or green, black, red. You see, this is time consuming. We're going to do it in this way, but we're going also to use the order method. So to choose a red ball, we have 4 different selections. Then for black, we have 7, and for green, we have 3. And then we repeat it 6 times. This would be 84 multiplied by 6, and this is because of the relation between addition and multiplication, which is 504. Or we can simply use red, black, green multiplied by the order. And remember the order of such a word. It's a word that contains 3 letters with no repetition, so it becomes 3 factorial, and 3 factorial is 6. Now, in how many different ways can these balls be selected if at least one red ball among the 3 selected balls is selected? So here we have at least one red. So we're going to have 1 red, 2 non-red, or 2 red, 1 non-red, or 3 red. So these are the different cases that we have. Now to choose a red ball, we have 4 possibilities. To choose a non-red, we have 10 possibilities. And to choose another non-red, we have 10 possibilities. Remember here the selection is with replacement. And the order in this case would be 3 factorial over 2 factorial, because we have 2 letters which are repeated. Or is represented by a plus. Now we have red, which is 4, another red, which is 4, and then non-red, which is 10. And this is the order. And in the third case, we have 4, 4, 4. And remember, we're not going to have an order because the order in this case is 1. So this is what we get. Now let's see this application. A bag has 5 blue cubes, 2 yellow cubes, and 4 green cubes. 4 cubes are selected randomly and successively with the replacement from this bag. So in fact, we have 11 cubes and we need to select 4 cubes successively with replacement. In how many different ways can these cubes be selected? Try to do it alone. So here we have 11 cubes and we need to choose 4 cubes out of them. So it will be 11, 11, 11, 11, which is 11 to the power 4. In how many different ways can these cubes be selected if they have the same color? Try to satisfy the condition. Try to do it alone. Because we need the same color here, so the cubes could be blue, 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 or yellow, 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 or green, 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 without any order. So this is 5 power 4, 2 power 4, 4 power 4. It would be 897 different ways. Now one might ask here, we just have 2 yellow cubes, how can we choose 4 yellow cubes out of them? Remember that the selection is done with the replacement. So we can choose 1 yellow cube, we replace it back, and then we can choose it, and then replace it back. If we need 100 times, we're going to get a yellow cube. Now, in how many different ways can these cubes be selected if exactly 3 green among the 4 selected cubes are selected? So here we need exactly 3 green, so in fact we are talking about 3 green and 1 non-green. Try to do it alone. So 3 green and 1 non-green multiplied by the order. Green we have 4 possibilities, another green 4, a third green 4, and then non-green is going to be 7, and the order we get 1792 different ways. Now, in how many different ways can these cubes be selected if at most 2 blue cubes are selected? So the condition here is at most 2 blue cubes. Try to do it alone. Well, at most 2 blue means 2 blue, 2 non-blue, or 1 blue, 3 non-blue, or 4 non-blue. In the first case, we're going to have 5 times 5 times 6 times 6. This 6 is the number of non-blue cubes times the order, which is 4 factorial over 2 factorial, 2 factorial. And then 1 blue is 5, non-blue is 6 multiplied by itself 3 times the order. And in the last case, we have 6, 6, 6, 6. And remember, we don't have any order. So this would be 11, 0, 16 different ways. So we've seen so far, remember, the successive drawing without replacement and the successive drawing with replacement. And we saw that they are similar in one way and different in another way. We will continue talking about the simultaneous drawing. Omega is a sample space. In a simultaneous drawing, we select P items at the same time. So if I want to choose 4 balls, at the same time I select them. An item could not be selected more than once, and the order in a simultaneous drawing is not important. An NU contains 2 red balls, 2 black balls, and 1 green ball. 2 balls are selected randomly and simultaneously from U. So we have 5 balls and we need to choose 2 balls simultaneously. In how many different ways can these balls be selected? Well, if the first ball is R1, the second ball could be R2, B1, B2, or G. You see here we don't have repetition. So these are the different cases. Now, if the first ball is R2, the second ball cannot be R1 because R2, R1, and R1, R2 are the same here in a simultaneous drawing. That's why we're going to eliminate this case. If the first ball is R2, the second could be B1 and could be B2, could be green. Now, if the first ball is B1, the second ball cannot be R1 because B1, R1, that's it. And then it cannot be R2 because this is R2 B1, and then the second could be B2 and it could be green. So these are the cases. We're going to consider 2 cases and eliminate 2 cases. And similarly here, and in the last case, we're not going to take any case into consideration. So what is the number of different ways? The number of different ways could be 4 plus 3 plus 2 plus 1, which is 10 different ways. And this is nothing but a combination. You see, the number of possible different selections is a combination NP, or the second form of the combination. Let's see some examples to clarify the idea. An NV contains 10 balls. We need to select 4 balls simultaneously from V. What is the number of different ways? So we're going to have a combination. Out of 10 balls, we need to choose 4 balls simultaneously, which is 210 different ways. Now in grade 12, we have 15 girls, 12 boys. we need to choose the 3 students simultaneously. What is the number of different selections? Try to do it alone. Well, similar to example 6, we're going to have 27 students and we need to select 3 out of them simultaneously, so it will be a combination. An NU contains 4 red, 7 black, and 3 green. We need to choose 4 balls simultaneously from U. So we have 14 balls and we need to choose 4 balls simultaneously. What is the number of different ways of these balls? In fact, we have a combination out of 14. We need to choose 4. So this would be the answer. Now, in how many different ways can these balls be selected if they have the same color? This is the condition. Now here, pay attention, we need to choose 4 balls having the same color. So these balls could be 4 red and could be 4 black, but cannot be 4 green. I cannot choose 4 green at the same time. So we have 4 red or 4 black. 4 red means out of 4 we need to choose 4, and 4 black out of 7 we need to choose 4. And this is the answer. In how many different ways can these balls be selected if exactly one red ball among the 4 selected balls is selected? So here we need exactly one red. If we need one red means we need 3 non-red. So this is 1 red and 3 non-red. 1 red means a combination 1 out of 4, and 3 non-red means a combination 3 out of 10. And it will be 480 different ways. Let's see this application. In a school we have 120 boys and 80 girls. We need to choose 3 students simultaneously to represent it abroad. In how many different ways can these students be selected? Try to do it alone. Remember, use combination because this is a simultaneous drawing. Well, out of 200 students, we need to choose 3. This would be the answer. Now, the condition here, we need to choose them having the same gender. Try also to do it alone. So same gender means they are 3 boys or 3 girls. 3 boys means 3 out of 120, or means addition, and 3 girls means 3 out of 80, and this would be the answer. Now, in how many different ways can we choose them if exactly 2 boys among the 3 selected students are selected? So we need here exactly 2 boys. Well, this means that we need 2 boys and 1 girl. 2 boys means 2 out of 120 and means multiplication, and 1 out of 80. You see here in a simultaneous drawing, we don't have any order. Now let's see a question containing different selections. In a computer store, there are 20 desktops and 15 laptops. Sammy wants to select 2 devices from this store. So Sammy wants to choose 2 out of 35 devices. In how many different ways can these devices be selected if Sammy selects the 2 devices successively without replacement? So we are in the first case. Try to think about the answer. In fact, this is an arrangement. We are choosing 2 devices out of 35, or it could be taken as 35 times 34. The total decreases by 1 because this is a successive selection without replacement. Now, in how many ways can these devices be selected if Sammy selects the 2 devices successively with the replacement? Try also to do it alone. So here we have 35 squared, or 35 times 35, which is 1225 different ways. And remember here the drawing is successive with the replacement, so the total does not change. Finally, what is the number of ways if Sammy selects them simultaneously? Try also to do it alone. So this is a combination. We are choosing 2 devices out of 35, which is 595 different ways.